Hello everyone. Let's talk about that cold shiver that runs down a researcher's spine at 2 a.m. You've got a peak. It's beautiful. Your mass accuracy is sub2 ppm. Your megasiemens per megasiemens fragments look like a textbook match. You're ready to call it L-isoleucine. But then, that nagging voice in the back of your head whispers, what if it's leucine? Today, we break that wall. We aren't just looking at weight anymore. We are looking at shape. In the old days, we called this the isomer wall. You could spend weeks on purification, or NMR, just to prove you weren't chasing a ghost. Today, we break that wall. CCS is the truth serum of mass spec. We aren't just searching for a needle in a haystack. We've given that needle a GPS beacon. We are going to learn how to access the global mind curated databases that hold the shape of almost every known molecule. This is the core of our philosophy today. Contrast the isolated researcher, guessing on their own, building libraries from scratch, against the connected specialist. The specialist knows that intelligence isn't just data. It's the strategic leverage of global knowledge. We don't reinvent the ruler. We use the library. CCS is the dimension that finally breaks the tie between structural isomers. In the past, we relied on a 3D workflow, m's per z, weight, RT, stickiness, and megasiemens per megasiemens fingerprint. But a three-legged stool is stable. A four-legged chair is a throne. CCS is that fourth dimension. It is an intrinsic reflection of structural arrangement, independent of LC gradient or column age. When isomers have similar fragments, their CCS values are the tiebreaker. You're giving your identification a physical passport. Actually, a 1% CCS error is more telling than a 5 ppm mass error. Why? Because mass can be tricked by isotopes or calibration drift. But for a molecule to have a 1% CCS deviation, its entire physical orientation must match. When you report findings, say, the candidate showed 0.8% deviation, confirming structural class with 95% confidence. This is how you speak the language of excellence. The isolated researcher builds their own library. The connected specialist leverages ccsbase.net. Developed by the Libenschuh Lab at University of Washington, it's a powerhouse, a double threat. It hosts massive experimental data, but also a machine learning prediction model. If your molecule hasn't been measured, it tells you what it should look like based on thousands of patterns. Metadata is king here. Note the drift gas, nitrogen. The McLean Group at Vanderbilt provides the unified CCS compendium. This is for structural purity. 3,800 experimentally acquired values from traceable molecular standards. What I love is the structural trends. It shows molecules follow corridors. If your unknown falls outside the peptide corridor but claims to be a peptide, the database is telling you, try again, kid. The physics don't match. Always differentiate between primary, measured, and predicted, machine learned. A match against a measured standard is a gold standard identification. A match against machine learning is a high probability lead. Know which one you're holding before you present it to your PI. And remember, METLIN and MONA are rapidly integrating these values. They are the global commons. How do we do this in practice? 1. The wide net. You have 5,000 features. Search against METLIN using M/Z. You get 50 hits for one peak. 2. The CCS filter. Pull values from CCS base. Suddenly, 45 hits are physically impossible, too bulky or too compact. 3. The surgical strike. You have 5 candidates left. Now look at megasiemens per megasiemens. By using the library early, you reduce false discovery exponentially. The specialist's mantra, don't reinvent the ruler, use the library. Intelligence is the ultimate separation tool. You now have the keys to the most sophisticated structural libraries in the world. Use them. Verify your suspects. Turn your maybe into a definitely. Stand on the shoulders of the giants at Washington, Vanderbilt, and the global MS community. Identifying the molecule is only half the battle. To get that perfect data, you have to understand where the magic starts, in the fire of the source. Join me in Module 5-1, the charge catalyst. We're going to dive into the heart of the MS source to understand the ionization physics that turn your neutral invisible samples into actionable data. I'll see you at the source.